Hello students, welcome to this week's radiography lecture on digital and 3D radiography. Digital radiography was introduced in 1987 and it requires no film and no processing. Instead, an electronic sensor produces X-ray images on a computer monitor. These are used for the same purposes as traditional radiographic methods. The electronic sensor is a charged coupled device, or CCD. It has an image receptor that is the same type of device used in video cameras and fax machines. The digital information is stored in units called pixels. The sensor is placed in the mouth and is activated by radiation, and then the computer stores and displays the image. The advantage of digital radiography is that it uses X-ray radiation similar to traditional methods. However, 50 to 80% less radiation is needed. The sensors are more sensitive to radiation than the film. For example, an e-speed film requires a 0.2 second exposure, whereas a digital sensor requires a 0.05 second exposure. In order to take digital X-rays, an X-radiation source, such as a conventional X-ray machine, is needed. You will also need an intraoral sensor and a computer. The sensor captures the images, and they can be wired or wireless. CCD is the most common, which is a solid-state silicone chip with an electronic circuit that is sensitive to X-rays or light. The sensor is placed in the mouth with a paralleling film technique and holders for stabilization. The sensor must be covered with a protective barrier, and it cannot be heat sterilized. CCD is a charged coupled device. The electrons on the silicone chip are arranged in blocks called pixels, which function much like the silver crystals. X-ray photons cause electrons to be released from the silicone, and it produces a corresponding electrical charge that is proportional to the number of electrons activated. An electronic latent image is produced and transmitted to the computer, where it is converted to a visible image. Each pixel is presented numerically by location and shade of gray. The pixel grayscale resolution is 256 shades of gray. The human eye can only see 32 shades of gray. Large number of gray shades allow manipulation of contrast and density without additional X-ray exposure. The computer digitizes, processes, and stores information received from the sensor. The image is produced on the computer screen within a minute. The software allows manipulation of the image color, magnification, measurements, etc. Digital imaging can be direct or indirect. In direct digital imaging, the sensor is activated by X-rays and sends the information to the computer. Indirect digital imaging can involve scanning an existing radiograph or the use of storage phosphor. Storage phosphor imaging is the method of obtaining a radiographic image by recording it on phosphor-coated plates and then putting it through an electronic processor where a laser scans the plate and produces an image on a computer screen. The phosphor plate itself is placed in a barrier envelope and positioned in the mouth for imaging, just like a traditional radiograph. However, instead of running film through chemicals, the plate is removed from the envelope and placed in the electronic processor, which digitizes the image and sends the information to the computer. The image is then erased from the plate, and the plate can be reused by being placed into another barrier envelope. The advantages of digital radiography are the superior grayscale resolution that can be attained. It also reduces exposure to radiation on the patient. It has an increased speed of viewing, overall decreased cost for film, developing solutions, and developing equipment, and most digital software allows for image enhancement. The disadvantages of digital is that the initial setup cost runs into at least $15,000, with each sensor costing $8,000 to $12,000 a piece. Then you also need computer and software. The sensor size is also a disadvantage. They're getting smaller but bulkier and not flexible like film. Infection control is also limited because they cannot be heat sterilized. Legal issues can crop up because the original image can be manipulated. Three-dimensional digital imaging utilizes cone beam computed tomography, or CBCT, also referred to as a CT scan. It is a method designed to evaluate the oral maxillofacial complex, and it is named because it uses a cone-shaped X-ray beam to acquire three-dimensional information. The source of radiation rotates around the head of a patient, much like a panoramic X-ray. Digital Imaging and Communications in Medicine, or DICOM, is a standard for handling, storing, printing, and transmitting information in medical imaging. It includes a file format definition and a network communications protocol. These images allow the practitioner to see the field of view in 3 dimensions. They are viewed in 3 planes: axial, coronal, and sagittal. When viewed together, images are referred to as multiplanar reconstructed images. They can be shared amongst dental professionals. CT scans required specialized equipment, or a CBCT machine. The radiation that exits the patient is received by a solid-state flat panel detector and becomes raw data that is sent to the computer. The number of manufacturers producing CBCT technology in dentistry is growing rapidly. The machine is comparable in size to a panoramic machine, and the patient sits, stands, or is placed in a supine position. In one rotation, radiation and receptor capture occurs in the field of view. A computer, viewing software are also required to allow the dental practitioner to view the axial, coronal, and sagittal images. CT scans greatly improve interpretation, diagnosis, and treatment planning of dental care. They are very valuable in implant placement, treatment planning, extraction or exposure of impacted teeth, definition of anatomic structures, endodontic assessment, airway and sinus analysis, evaluation of TMJ disorders, orthodontic evaluation, and pathology evaluation. Comprehensive examination and interpretation of images should be completed and documented with the overall health of the patient in mind. It is critical to refer to the manufacturer-provided instruction booklet for information concerning the operation of the system, equipment preparation, patient preparation, and exposure. The patient is instructed to remain still. Scan times vary from 7 to 30 seconds. Ergonomic head and chin supports have been designed for improved patient comfort. Laser beams may be installed to help with proper alignment of clinical structures and to ensure correct anatomic positioning. The advantages of three-dimensional imaging is a lower radiation dose, a brief scanning time, anatomically accurate images, the ability to save and easily transport images. The disadvantages of digital radiography is as the patient moves, you get artifacts, the size of the field of view, the cost of the equipment can be exorbitant, and lack of training in the interpretation of images on the data outside of the maxilla and the mandible. CBCT machines currently range in cost from $150,000 to $300,000. Training must be complete to use the equipment properly, as well as training of the doctor in the interpretation of images. This concludes this section on dental radiography.